Alright, I'm going to go over two more examples of how to use the technique of elimination to solve a system of linear equations. Now in example 3, we have positive 6x minus 10y equal positive 10, and the other equation is negative 6y minus 8x equal 6. Now realize that these two linear equations, they are not lining up accordingly, so I want to make sure that I line up the x and the y accordingly by switching places of the x and y in one of the equations. So I like to have the x first and then the y later from left to right. So I'm gonna switch places of x and y in the second equation. So keep the first one the same. And then I'm gonna have 8x minus 6y equal to 6. Now, unlike the previous two examples, when I compare the x and the y's vertically, none of these coefficients are the opposite of each other. Meaning 16 and negative 8 is not the opposite of each other, and negative 10 and negative 6 are not the opposite of each other. But what I can tell is that if I compare, for example, let's just say I want to eliminate the x. So I compare the coefficients of the x, negative 8 and 16, and I realize that negative 8 is one of the multiplicative factors of the larger coefficient 16. So because of that, that means I can go ahead and try to convert the smaller coefficient into the opposite of positive 16, which is negative 16. Well, that's going to be easy because if I multiply the entire second equation by another number, in this case, that other specific number is going to be positive 2. That means my new second equation, when I multiply this positive 2 into every term of this second equation, I'm going to be having negative 16x minus 12y equal to positive 12 as my new second equation, and the first one stayed the same. So bring it over. To 10. But hey, now that I can easily eliminate the x because the coefficient of this x is 16 and the coefficient of this x is negative 16, and they are the opposite of each other. So adding these two equations vertically, this will be reduced down to 0x, and then negative 10y minus 12y is negative 22y, then equal to 10 plus 12, which is positive 22. Anything multiplied x is just 0, so we're left with negative 22y equal to 22. To get y by itself, doing the opposite of multiplication, which is division, divide both sides by negative 22. But hey, we got y equal to negative 1. So that's one variable known. To find the other one, take the value of the one that we just found and plug it into one of the two original equations. I'm going to go with the second one, but you're more than welcome to pick the first one. So for the second one, I'm going to have negative 6 times y, which is negative 1, minus 8 times x equal to 6. Negative 6 times negative 1 is positive 6, minus 8 times x equal to positive 6. To get x by itself, I had to eliminate from outside in. So I had to get rid of a 6 and a negative 8 later. So subtract 6 to both sides. The 6 on the left cancel out. I got negative 8x equal, well, 6 minus 6 is going to be 0. Getting x by itself by doing the opposite of multiplying negative 8, which is dividing both sides by negative 8. I have x equal 0 divided by anything is 0. So the solution to this system, aka the point of intersection of this system of linear equation, is 0, negative 1.